The next property is multiplication in time domain property. Here the another name for this multiplication in time domain is modulation property, that is x1 of t, x2 of t multiplication in two signals in time domain is equivalent to convolution of the two signals in frequency domain. We need to prove this. So here y of j ohm is equal to integral minus infinity to infinity this y of t e power minus j ohm t dt. So y of t is nothing but x1 of t into x2 of t, substituting in this equation e power minus j ohm t dt. Then what we are going to do is here for x1 of t I am going to substitute the formula. X of t formula is 1 by 2 pi integral minus infinity to infinity x1 of j ohm. So already here you are having ohm, so you will get confused. So what you are going to do is you are going to take an ohm which is equivalent to lambda. Here the lambda is also a frequency component here, x1 of j lambda e power minus j lambda d lambda. Okay, so here what I am doing is just we are writing this combining these exponential term. What you will get is e power j ohm minus lambda d lambda dt I am getting. So rearranging this term, 1 by 2 pi integral minus infinity to infinity x1 of j lambda, this remaining term I am considering as x2 of j lambda minus, that is ohm minus lambda. Either you can have ohm 1 instead of lambda if we have confusion in lambda, so d lambda. So these two term and this dt combined together and we are having x2 formula, that is x formula. Okay, so this is nothing but convolutional formula, one signal as such, another signal reversal and shifted. So this is nothing but the convolution property. So the next one is convolution in time domain. So similarly here two signal I am considering. Now I am going to perform convolution in time domain signal, which is equivalent to multiplication of the signal in frequency domain. Okay, so the same procedure I have considered y of j ohm integral minus infinity to infinity y of t e power minus j ohm t dt, which is equal to integral minus infinity to infinity x1 of t convolution x2 of t e power minus j ohm t dt. So this is the convolutional formula for x1 of t, x2 of t is minus infinity to infinity x1 of tau, x2 of t minus tau d tau. So here y of j ohm is minus integral minus infinity to infinity integral minus infinity to infinity. So here for this one I am substituting this formula x1 of tau, x2 of t minus tau d tau e power minus j ohm t dt. So I am taking this lambda as t minus tau, and when I differentiate d lambda is equal to dt. So integral minus infinity to infinity integral minus infinity to infinity x1 of lambda, x2 of x1 of tau, x2 of lambda d tau e power minus j ohm t. This t can be now here x1 of lambda e power is splitting this e power minus j ohm lambda d tau minus infinity to infinity. This is minus j ohm tau d tau. So here lambda, here d lambda. So this is nothing but x1 of j ohm and x2 of j ohm. So the convolution of the signal in time domain is equivalent to multiplication of the signal in frequency domain. Next one is differentiation in time domain. This is what x of t j ohm, the first default step. Here we are going to differentiate the time domain signal. So when I differentiate the time domain, what I will get is I will get j ohm in addition to x of j ohm. So this is the x of t formula 1 by 2 pi integral minus infinity to infinity x of j ohm e power j ohm t d ohm. Differentiating this, so what you will get is d by dt x of t. So putting d by dt, because a differentiation term here only you are having e power j ohm t. So d by dt j e power j ohm t into d ohm. So 1 by 2 pi. So when you differentiate this, what I will get is I will get j ohm. So integral minus infinity to infinity x of j ohm e power j ohm t d ohm. Okay, now this is what the x of j ohm formula. So if you put a transform, this represent x of t formula. Okay, so similarly here if you have n, here you will have x of j power j ohm n. The next one is The next one is differentiation in frequency domain. X of t is equal to x, that is Fourier transform is x of j ohm. So here we are going to differentiate in frequency domain. So d by d ohm x of j ohm. So what is the term you are getting in time domain is minus x jt. So x of j ohm is equal to integral minus infinity to infinity x of t e power minus j ohm t dt. So when you differentiating this, the only term related to ohm is this term. So d by d ohm e power minus j ohm t dt. So what I will get is minus jt I will get when I differentiate this. So minus jt, this term represent x of t. When you apply transform for this become x of j ohm. Do you understand the difference? So this is what your minus jt into x of t. Okay, so this is what the thing. So finally, if it is minus jt the whole power n, you will get dn by d ohm x of j ohm. Okay, so the next property is the conjugation property. So x of t, x of j ohm, conjugation, what you will have is here x of minus j ohm. For that, here we are going to take x of t equal to 1 by 2 pi integral minus infinity to infinity x of j ohm e power j ohm t d ohm. I am taking conjugate. So this x signal will get conjugate. So this is a complex term. So you will get e power minus j ohm t d ohm. So 1 by 2 pi integral minus infinity to infinity x conjugate of j ohm e power j. So this term, remaining term, can be combined with ohm dt d ohm. In order to apply this formula, x conjugate here. So what you are having for ohm? Minus ohm. So minus j ohm here we are having. Next one is Parseval's relation. Parseval relation relates the energy of a continuous time aperiodic signal in time domain to the energy of its spectrum. So x of t, this is the formula, we need to prove it. Okay, so I am taking this formula minus infinity to infinity mod x of t the whole square dt. This can be written as x of t x conjugate of t. So here minus infinity to infinity x of t, for x conjugate of t I have applied the x of t formula and I am taken the conjugate. So here this is d ohm and this is dt. Okay, next what I have written is 1 by 2 pi, the same thing. Here I have rearranged it. So what I have x of t e power minus jt I have bring here, then dt, the remaining x of conjugate of j ohm d ohm I have bring this side. So this formula is nothing but x of j ohm formula. So x of j ohm, again I am having 1 by 2 pi integral minus infinity to infinity. So this is, if for this one it is x of j ohm. So this x of conjugate of j ohm d ohm is there. Similarly here I am having this integral I am having here. So 1 by 2 pi integral 1 my integral that is magnitude of x of j ohm the whole square into d ohm. Okay, so this is what the Parseval's relation. So the next property is the duality property. So what is the duality represent is time domain in t we are having a variable t. So the here now we are going to replace with ohm. Okay, so here for that x of jt is equal to 2 pi x of ohm. T you are having j, for x of t I am having t. So x of t equal to 1 by t integral minus infinity to infinity x of j ohm e power j ohm t d ohm. Now replacing t by minus t. So I have replaced wherever I am having t, I have replaced t by minus t. So I have written this equation. Next replace t by ohm. So what I am going to do is here 2 pi I am bringing here, 2 pi I am bringing here x of minus t minus infinity to infinity x of j ohm. Wherever I am having t, there I am going to replace ohm. So here this t already we have replaced t by ohm and ohm by t. So here minus j ohm t d ohm here you are having. So here replacing t by minus ohm, then here ohm by t, then this ohm by t and this t by ohm and this ohm by dt. Okay, so wherever we are going to we have to replace this t by ohm and ohm by t. So I am getting 2 pi x of minus ohm is equal to this one. So this is nothing but x of jt and this is 2 pi x of minus ohm. Okay, so this is what the duality property. The next one is conjugate symmetry property, the last property. We have already discussed similar property in Fourier series. If x of t is real and x of t real, both x conjugate of t and x of t are same value. Similarly, in frequency domain, x conjugate of x of ohm and x of j ohm are same. Next, x of t is even, x of t equal to x of minus t, and x of j ohm is equal to x of minus j ohm. These both are same and these both are same. If x of t is real and even, x of j ohm is also real and even. Next cases, x of t is odd signal, the x of t is equal to minus x of minus t, and x of j ohm is equal to minus x of j ohm. The next case is x of t is real and odd, x of j ohm is purely imaginary and odd. Here it is not real, it become imaginary and odd. And if x of t is real, then the angle, both the angle are same, that is magnitude of angle are reverse, that is x of j ohm is equal to minus x of minus j ohm, and the magnitude are same, magnitude of x of j ohm is equal to magnitude of x of minus j ohm. Okay, so that's what about the properties of the Fourier transform. So I hope you have understand all these concepts. In the next class, what we will do is we will solve some problems related to Fourier transform, and next we will go for the next topic. Okay, so if you have any doubt, you just ask me and clear all your doubts before going to the next topic. Thank you.